Hello everybody, this is Naveen S. Sapare, Assistant Professor, Department of Mathematics, KLIT Hubli. So here I am with you to teach you the topic Fourier transform. So before going to the topic Fourier transform, we just go through some basic concepts. So I will discuss the following basic concepts here. The first one, periodic function. Second one, amplitude. Third one, frequency. Fourth one, time domain. What's the meaning of time domain? I will discuss. Next one, a frequency domain. Sixth one, transform. So let us discuss some basic concept. So we start with the periodic function. So periodic function is a function where the function repeat its value for the fixed interval, and we denote the interval as capital T. For example, if I take a function f of t is equal to sine t, then I can say that the sine function is a periodic function with a period t is equal to 2 pi. Why the period of the function sine t is 2 pi? It is because the sine function repeat its value for every 360 degree. That is, we know that sine 0 is 0, sine 360 is again 0, sine 720 is 0, and so on. It means that for every 360 degree sine function will repeat its value. That's why such functions we call them as a periodic function. And since all the trigonometric functions are periodic functions with different periods, that is capital T. In a similar way, what is amplitude? So I will draw a graph here. Assume that this is the curve, and this is, I will consider it as a mean position. So amplitude is nothing but the maximum displacement of a curve from the mean position. Okay, so here this distance or maybe this distance, both are representing the amplitude. In a simple word, I can say that the maximum displacement, this length, the maximum displacement of the given function from the mean point will be called as amplitude. In a similar way, frequency. What is the frequency? We know that these are the waves, or we can say the curves. So frequency is defined as the number of cycles occur per second. Number of cycles or number of waves. Okay, number of cycles or number of waves which occur per second will be called as a frequency. So the next one is time domain. What is the meaning of time domain here? So I will take an example here. When I take a function y is equal to f of t, here y value changes with respect to time, or maybe the properties of the function y is equal to f of t changes with respect to time. And graphically we represent it as, I will take this axis as a time axis and this as y. So here for this particular function, y changes with respect to time. As the time changes, then definitely y also changes. Or in a simple way, I can say that the properties of the function changes as time passes. It means that the properties are depending on the time. So such representation of a graph of a given function will be called as a time domain of a given function. Okay, so in a simple way we can say that here the curve is changing with respect to time. So such representation of a given function will be called as a time domain of a function. And next one is the frequency domain. What is the meaning of frequency domain? So I will draw a curve again. So here this is frequency, and obviously this is the properties of the function. One example I will take, a sound function. So in sound function I am taking a air pressure. So now air pressure, now obviously what is the meaning of frequency domain means, in a frequency domain of a given function we study what will be the air pressure at the particular frequencies. Okay, what is the time domain? Time domain means just we will study how the properties of a given function changes as a time passes. But in a frequency domain what we study is at the particular frequencies what will be the property. For example, if I take a sound function here, in this sound function, if I express this sound function in a frequency domain, then from this I can study at a particular frequencies what will be the air pressure. So that is called as the frequency domain. And the next one is transform. Obviously we know that transform means a change, changing one form to other form. If I take an elementary example, that is, if I want to travel from one place to another place, definitely to move from one place to other place I can go by walk. Obviously when I go by walk it takes much time. If the distance is very much far, then definitely most of the time it is not possible to move by walk. In that case, what is my mode of transportation? Obviously if the distance is less, then definitely we can go by walk. Here my mode of transportation is just by a walk. But if I want to travel a long distances, definitely that time my mode of transportation changes its form. Changes its form means definitely I can go the distance or the destination where I want to move. Definitely I can take a bus, I can take a vehicle, car, or maybe I can take a flight. It depends on what distance I am moving. So here the mode of transportation is changing by vehicle, car, bus, or flight depending on the distance which we need to travel. So here the mode of transportation is changing. So that change of mode of transportation will be called as a transform. Obviously it changed from walking to bus, train, or maybe flight. The mode of transportation is changed. So that change is called as a transform, or maybe we can say transformation.